First of all, both public and private water well systems have been shown to have PFAS, most notably PFOA and PFOS, the two that have received the most attention. And also, these are not the only sources of PFAS that we have in our homes. It's important to keep that in track too, because we have food and many consumer products that expose us to it. I guess one of the factors is that extending public infrastructure can be very, including both water and sewer, can be substantial costs, and installation can be very disruptive. Also, if you're from a rural area, you're most likely to connect to a small community water system, and these are the water systems that have most likely to have violations of EPA drinking water standards. Those are the ones that face a lot of challenges just in recruiting and retaining operators, and they have limited financial technical resources, and also diseconomies of scale. In other words, fewer households means higher costs per household in general. So there's the issue there. And then I think finally, private wells can be rendered safe through a combination of proper well design and either point of use or point of entry water treatment. And these systems have the additional benefit of removing other contaminants that might be in the well water, such as trace organics or arsenic or taste and odor. Okay, so both POU and POE systems can be effective at reducing PFOA and PFOS. Third-party certification is very important, and that's available for activated carbon filtration and for reverse osmosis systems. And that certification, they look at the material safety, the integrity of the system, the product literature, how well it describes how it works and how to maintain it and how it performs. So there's two standards. There's an NSF ANSI standard 53 for the carbon-based systems, and there's a ANSI standard 58 for reverse osmosis systems. And there's a couple dozen companies, I think, out there with products that are certified by NSF, as well as by the Water Quality Association for the reduction of PFOA and PFOS. So the point of use systems, typically is at somebody's sink, right? So you have limited coverage in the home. So it doesn't really address other exposures that you might have, like dermal exposure while showering or bathing, and sources of drinking water in other parts of the house, unless you have a whole bunch of these point of use systems. They're going to lower the flow rate because it's serving a single faucet. So that's another consideration. Point of entry systems, you have a whole house cartridge filter. I think one of the advantages is that typically you might have a longer filter life in that case. You don't have to worry about bottled water purchases for your bathroom or something like that because you don't have the point of use system there. And you're going to get better whole house flow rate reduction from those systems, less impacts, I would say. Attention being given to it, that's for sure. It does present a challenge. I mean, PFAS are stable, they're mobile in groundwater, and they typically are a complex mixture. And at the parts per trillion levels of concern, they can form these large diffuse plumes. And then there's other issues like air transport from manufacturing facilities that add complexities. But aside was sort of in the early stages of it. Aside from you can excavate the sources. We're somewhat back in the days of pump and treat as a primary remedial option at the moment. But there are other techniques that show promise that are being employed in places like dispersed colloidal activated carbon to retard PFAS movement underground. And there's lots of research going on possible bioremediation and advanced chemical oxidation approaches. We're not starting from scratch as much as we were when we first addressed chlorinated solvents. So we've learned a lot over the years in addressing particularly smart characterization of the problem. So we have many tools to map out subsurface conditions and determine conceptual site models to get a handle on where the primary flux is taking place. There's methods of real-time characterization to analyze samples on site or progressing to help with that. And again, there's lots of research underway on treatment technologies at the land surface too. So in addition to the granular activated carbon and reverse osmosis we spoke about for homes, there's a lot of effort going towards ion exchange resins of various types. So there's a lot of work going on to try to figure out how to address this problem underway.